Okay, time to take a look at some complex fractions or complex rational expressions. So this is like your worst nightmare because it's a fraction within a fraction. We have two examples here. You can see we have the numerator, I'll circle that in green, has a fraction in it, and the denominator, circled in purple, also has a fraction in it. Same thing in this next one, a fraction within a fraction. Well, math people don't like this any more than anyone else does. So we usually want to simplify a complex fraction, and that means to write it as just a reduced fraction in lowest terms. And there are two ways that we can do that, and I'm going to show you both of these methods. Option one says treat the numerator and the denominator of the complex rational expression separately, performing whatever operations are indicated and simplifying the results. Follow this by simplifying the resulting rational expression. So that's option one. Or option two is find the least common multiple of the denominators, and that means all the denominators of the rational expressions that appear. Multiply the numerator and the denominator by that least common multiple or least common denominator and simplify. So I'm going to do some examples where we use option one, and we're going to do some examples where we use option two, and I'll make sure to point that out to you. So we're going to start off with just some numeric examples. Well, I guess one numeric example, and then we'll go straight on to the variables. So for this first one, we have a fraction within a fraction. We have 3/5 on the top and 11/20 on the bottom. So if we wanted to, we're not going to take this step every time, but we could rewrite this. That is equivalent to 3/5 divided by 11/20. Okay, so that denominator is really what we're dividing by. And remember, to divide fractions, we want to multiply by the reciprocal. We skip the first fraction, we flip the second fraction, and we multiply those two new ones together. Skip, multiply, flip, or skip, flip, multiply, if you might have learned that in the past. 3 times 20 is 60, and 5 times 11 is 55. And then you got to be careful here. I didn't reduce anything before I multiplied. So now this is not in lowest terms. That numerator and that denominator can be both divided by 5. So if we reduce that fraction, we get 11/12 for our final answer. Okay, that was option number one. And these first several we're just going to do with option one, okay, where we here, the numerator and the denominator are both a single fraction already, so that's good news. So all we have to do is rewrite this as a division problem, -2/15y squared divided by, so that means we are going to multiply and flip 21y cubed over 8. This time I am going to do a little simplifying before I multiply through to make our next step easier. So I see a -2 on the top and an 8 on the bottom. Those can be both divided by 2, so that becomes a -1 up top and a 4 on the bottom. I see a 21 on the top and a 15 on the bottom. They can both be divided by 3. And then finally, I have y squared on the bottom and y cubed on the top. Using our rules for exponents, y cubed divided by y squared is just y. So these are going to reduce to just a plain old y. So kind of put together all the scratches I have up here. I have a -1 times 7 times y. So up top, -7y. On the bottom, I just have 5 times 4. So 20. There's my simplified reduced fraction. No more complex fractions there. Okay, again, still using option number one for all of these. Next up, number 3, I have 30 over z minus 2 times, flip that upside down because we're dividing by that second fraction, z minus 2 over 10. Okay, it might help you visualize what you're allowed to cancel if you put parentheses around those expressions. So we can see we have 30 times z minus 2 over z minus 2 times 10. Since those are multiplied together, since they are factors, we can cancel each of those. And 30 over 10, that they are both divisible by 10. So if we cancel 10 from both of those, we just end up with 3/1, or just 3 for our final answer. Next one up, we're going to do the same thing. Option number 1 again, we take that fraction that's on the top, and as I rewrite it, I'm going to factor that denominator because that's going to help in our next simplifying step. That is the difference of difference of two squares. And we multiply it by the reciprocal of what we have underneath. So again, looking for what we can cancel. If it helps, think of that as in parentheses. So x times x plus 2. So we can see right away that the x plus 2's can cancel each other. And what we have left behind is just the x on top and just the x minus 2 on the bottom. We cannot cancel those two x's because this is not factored. Those are two separate terms on the bottom. So no more canceling. That's it. That's our final answer for number 4. Okay, these next examples are where you'll really see the difference between when I do option 1 and option 2. Those first few, we really were just doing a division of fractions, okay? But you'll notice here in number 5, we have the numerator and the denominator, and they are not each a single fraction. The numerator is an expression, and the denominator is an expression. So option number 1 says, do the math, turn that into a single fraction. So remember 2 is the same as 2 over 1. And if we want a common denominator up in our numerator, we'd have to multiply that by x over x. I'm going to go ahead and finish this out before I work on the denominator. So you can see now we have a common denominator of x, and up top we'll have 2x plus 1. Okay, I'm going to do the same thing to the denominator. That 8 can be written as 8 over 1. And if I want that to have a common denominator, I need to multiply that one by x over x. And what I have then is 8x minus 1 over x. Now that I have a single fraction on the top and a single fraction on the bottom, then I can do this the same way I've been doing those other examples as we started the video. Take the fraction that was up top, multiply it by the reciprocal of the fraction that was on the bottom. Okay, when we do that, those x's can cancel each other. And we end up with 2x plus 1 over 8x minus 1. Cannot reduce that 2 and that 8. Those are terms, not factors. So that is our simplified answer. Okay, next one, number 6. For number 6, we do have, it's not a fraction, but we have a single value in the numerator already. So I'm going to leave that alone for a minute. The denominator has a common denominator, so it's not a single fraction, but we can go ahead and add it up. 5 plus 3 is 8 over x. Okay, so if we want to rewrite that as a division problem, x over 1 times the reciprocal of 8 over x, which is x over 8. Multiply the tops, we get x squared. Multiply the bottoms, we get 8. Okay, those are all still using option 1. Okay, in this one, number 7, I'm going to show you for the first time how to do option number 2. So if we were doing option 1, we'd need a common denominator on the top and add those two together. And we'd need a common denominator on the bottom and add those two together. But instead, we're going to try option number 2 for this one. Let's pick a different color since we did just light blue before. Okay, and option number 2 says find the LCD of all of the denominators you see. Okay, we have 4 denominators up here in this problem. So the LCD needs to cover all 4 of those. So the LCD would be, well, it has to have an a squared in it, and it has to have a b squared in it. Double check, does that cover all those denominators? It does. So what we're going to do is we are going to multiply the top and the bottom of this whole original fraction by that least common denominator. And remember, when we multiply by a whole number, it's like multiplying by that number over 1. So we're multiplying this fraction top and bottom by the same thing. And that thing we're multiplying by is the least common denominator. So we want to distribute that to each term. Okay, so what we end up on top is 8, 5, a squared b squared over a squared b plus 3a squared b squared over ab squared. We'll do the same thing on the bottom. Notice it's only changing the numerators because we're multiplying by something over 1. Those denominators are just getting multiplied by 1, so they don't change at all. So on the bottom, we end up with 1 times a squared b squared minus 6a squared b squared. Okay, this is where the fun happens. Now, in each one of those individual fractions, we want to do any canceling that we can. So in this first one right here, we have 5a squared b squared over a squared b. So those two a squareds cancel each other. We have two b's on the top and one b on the bottom. So this cancels and we just have one left on top. So from that first fraction, all we have left behind now is 5b. Now our second fraction, we have two a's on the top and one on the bottom. So we'll just be left with one on the top. Two b's and two b's, those just knock each other out. And we are left with just 3a. In the denominator, the a squareds cancel. One of these b's cancels with that one, and we are just left with a single b. And then this time, one a cancels and both b's cancel, so we are just left with 6a. And that is fully reduced. Okay, that is option number 2. So there's 2 different ways you can handle these. I'm going to try one more example of each method so you can see it. Okay, number 8, I'm going to go back to option 1 for number 8. So you can see the difference between the two. Option 1 says take your numerator and do the arithmetic, turn that into a single fraction. So I don't need the LCD of all 4 of these fractions, I just need a common denominator up top. So I'm going to take that 1 over m and multiply it by 7n over 7n. And then I take my 2 over 7n and multiply that by m over m. Again, right here, I'm just getting a common denominator on the top. So I have a common denominator now of 7mn, and then the math across the top is just 7n plus 2m. Okay, now let's look at the bottom. Now I need a common denominator just between these two fractions. So I started with 1 over m. I need to put in there a 4n for our common denominator, minus 3 over 4n. I need to multiply the top and bottom by m. Okay, so now I have a common denominator on the bottom of 4mn, and up top I have 4n minus 3m. And this is where it's going to look like the beginning examples that we started with. We had a single fraction on the top and a single fraction on the bottom, so we can rewrite that as a division problem, which is multiplication by the reciprocal. So we'll flip that second fraction. Remember, these are multiplied. So we can do a little canceling there. That m goes with that m, and that n goes with that n. And our final answer, I'm going to write the coefficient out front, would be 4, 7n plus 2m over 7, 4n minus 3m. Again, that was option number 1. For the final example, I'm going to go back to option number 2. So you can see that method again. For problems like, let's see here, 7, 8, 9, I really do prefer option 2, but if you like option 1, that's fine also. Option 2 says figure out the LCD. So on number 9, you want to look at all 4 of those fractions. And in this case, the LCD would be x plus 4, x plus 5. Okay, and then we are going to multiply the top and the bottom by that LCD. Okay, if we multiply the top and the bottom by the least common denominator, it's really like multiplying by that thing over 1. Okay, so we need to distribute back into our original. This whole thing gets distributed into both of those terms. So let's see what we got there. We'll have x plus 4, x plus 5 over x plus 4. That's when we distribute it to the first fraction. Then we'll have a 3, x plus 4, x plus 5 over x plus 5. That's what happens when we distribute it to the second fraction. Then we'll do that same distribution down here. And we'll get a 2, x plus 4, x plus 5 over x plus 4. Let me scroll down just a little bit. And then when we distribute it to the second fraction, careful, there's a minus sign in there. Don't lose that. Minus 1 times x plus 4, x plus 5 over x plus 5. Okay, seems like a lot of mess right there, but this is where the magic starts to happen. Then we can do all kinds of canceling. There should be cancellation that occurs in all 4 of those fractions we see. So in this first one, the x plus 4s. In the second one, the x plus 5s. In the third one, the x plus 4s. And in the fourth one, the x plus 5s. And let's see what's left behind. We are left with an x plus 5 plus 3, x plus 4. That's my whole numerator after I've canceled everything out. On the bottom, we're left with 2, x plus 5 minus x plus 4. Looking good. Now we just need to distribute, collect like terms. I might run out of room down here. Let's see. Maybe I'll come all the way over here. So we have x plus 5, and then distribute that 3 plus 3x plus 12 over, distribute the 2, 2x plus 10, distribute the negative, minus x minus 4. Combine like terms. Up top, we've got an x plus a 3x, and 5 plus 12. On the bottom, 2x minus x, and 10 minus 4. There we go. That would be our final answer. It's a good idea to go ahead and try some of these on your own. Maybe try them without the video and then come back and check your work. And that's it for this one.